Hello students. In this session, we will discuss about the very important application in industrial as well as in automation, the most important application PLC. PLC is nothing but programmable logic controller. That means whenever if you write a program with a logic may be AND gate, OR gate, addition, subtraction, all those things, by applying to the device, it will control our requirement. So PLC means programmable logic controller. So it will take program and it will store it the program and it will control our required output. This is the programmable logic control. The shortcut name is PLC. So in this PLC, if you look at the definition, a PLC is an industrial microprocessor based controller. A simply industrial, it has a microprocessor. It has microprocessor means microprocessor is nothing but it is a processor. It will execute our requirement. It will take inputs and it will execute our required output with programmable memory. That means it will take program. It will take program and it will store that program. Used to store the program instructions. So why we are writing the programs? To give the instruction, to give the input. By taking the input, give some output and various functions in order to do the various functions. Simply, PLC is a microprocessor based controller and it will takes the input in terms of programs and it will gives the output whichever required function. Whichever the required function. Simply a microprocessor based controller. And a programmable logic control is often described as a mini computer. We can name it as simply a mini computer that can be communicate with the different objects, systems and machines. By using that, we can communicate with different objects and different systems and different machines. They are designed to control and troubleshoot the network. That means it is used for designing a network or troubleshooting a network. Troubleshoot means repairing a network. If any fault occurred in the network, that will be repaired by this our PLC, which is why they are necessary components of SCADA. Generally, these have more applications, different features. Those features are very applicable using these are necessary components to SCADA. That's why it is very much applicable in SCADA. What is SCADA? Supervisory control and data acquisition. In this SCADA also it is very applicable. So simply PLC means it is a microprocessor based controller. It will take input as in terms of programs and it will gives our required output and it will control that output also. Generally, PLC block diagram is like this, and this is in our laboratory, in our control system laboratory, we have this prototype PLC. So first we will look at the PLC. PLC means this complete system is the PLC. In this PLC, look at here, it is input module. Input module means it will take input, any input. These are switches actually. These are switches. Any type of input. It will take open switch. It is a closed switch. It is some other switch. It is a different switch. We have number of types of inputs. And in order to operate this input module, it requires some power supply. This is our main PLC component. This main PLC component have the CPU, Central Processing Unit, and it has a memory unit. And it will take some program, it will store the data. And look at here, it will give our required output any form of, it will control the motor, it will control the device, it will control something, anything. These are the output modules. So it will take the input and it will take the output. And it is a CPU controls this input and output. But always This is not completion, but it requires another device, that is our personal computer. Why the personal computer? In order to operate this PLC, that means it will take the input and give the output, it requires a program. We can control from here. So in order to write the program, we have a programming device. That programming device is our personal computer. The personal computer, we can write the program in the software, that is the ladder program. The ladder program will be downloaded. The downloaded ladder program will take by this PLC by following the instructions from the program. It will decide which input it will take, and it will decide which output it will take. The complete input and output control is done by this personal computer programming, that is the ladder programming. So we have uh, different types of softwares to write this program. The written program will be taken by this our PLC system. In this PLC system takes the inputs and gives our required outputs. So look at here, this is our laboratory PLC. In this laboratory, just observe here, this is first, look at this screen. This screen is HMI. Actually this is HMI, human machine interface. So actually it is applicable in SCADA, it is not required in the PLC. So keep away this part, HMI part. Our requirement is PLC platform only, PLC platform. In this PLC platform, CPU is, this is our CPU. This is our central processing unit. This is our central processing unit. And it will take the program and it will execute the program. And look at here, these input modules are nothing but these are the input modules. This left side complete part is the input module. Here input modules are, this is the, if you observe here, this is the push button. Red color is the push button, and these are the toggle switches, on and off toggle switches. This is also one type of input. And we have infrared sensor, IR sensor. Infrared sensor means whenever object near to this, by observing that it will operate. And this is the limit switch. By pressing this switch, it will operate as a switch. And these three inputs can be used for the PLC. And output representation. One of the output representation, these are the LED bulbs. So output can be represented in the form of LED bulb. So lights will be blown, lights will be blown, but these are the LED bulbs. So another form of output is the buzzer. It will give the sound. This is one of the output. The another form of output is the it is a simple DC motor. Whenever output is high, this motor will be operated. Then the another output is the pilot lamp, a single lamp. Pilot lamp output is operated, it will be show the output. And this is we have a relay. These are the relay sensors. They are operating the relays. These are the relays actually, right? Okay, but look at here. This is another module is there. This is also PLC module. This is actually the designed PLC module, but this is the PLC, but we can take inputs from outside. It will take output from another side. It will take input from answer. So that's why you look at here. This module is separately take the input and inside connected to this, and by connecting these devices, and we can use the output. So practically we can use this. So but it is also another thing. It is also one PLC module. This is also one PLC module. In our experiments, we are using this PLC module. These are the push buttons and toggle switches. IR sensor, limit switches are input for this device, and this LED bulbs, and this is buzzer, and this is DC motor, and this is pilot lamp. This is the relays. Look at here. If you observe here, this is connected by this input. this is also connected by the input, and this is also connected by this input, and this is for this out. Look at here, from this PLC it is connected to this LED bulb, this is connected to this LED bulb, this is connected to DC motor. So these are the outputs actually. Simply this input module represents this input modules, and our CPU and PLC system is, this is our CPU and PLC system, and output module is, these are represents the output modules. And we have a personal computer from outside. So from this personal computer a communication port is connected here, communication port is connected here, and we have the programming port also connected here. By connecting these two ports, the communication between the personal computer and our PLC kit will be enabled. And this is the power supply. This, whenever we are switch on this power supply, this will be operated. Look at here, this is power supply, this represents a power supply. So the power supply is applied to input module and the CPU and output module. So whenever you are starting the PLC kit, in order to operate the PLC kit, you have to on this. This is about our PLC in our laboratory. Okay. Next we will look at, but we will discuss the how to write the program, how to execute the program in the next sessions. Whenever we are doing the experiments, we will discuss that. But we will look at some applications regarding the PLC. We have, in our industry purpose, we have more number of applications in PLC. The first application is the control of cutting machine with variable length. Look at here, this is the cutting machine actually, this is the motor, this is the cutter. So this controlling of the length, how, so look at here, this is the cutting length, these are the cutting length. The cutting length, how much of length it should be cutting will be decided by this PLC, Look at here. So if you want to cut some 10 meters, the 10 meter will be given by this cutting length setting. Program will be applied to this PLC. This is the PLC kit. Then the PLC will apply the speed command to this inverter. The speed will be decided by this motor, and the operating of the motor will be decided again by the PLC. Look at here. This is the encoder. You're giving some code to this. So by this code, the DC motor will be operated. Then DC motor for particular length will come, automatically it will be off, and again particular length will come, automatically it will on. Okay, this is the roller actually. This roller will be decides. Understand? So automatically the motor will be operated. There is no requirement of the manpower here. So that will be decided by this PLC. By operating the PLC, we can get our required length. So this is the one of the best application of the variable length. Next application is 3-axis position control. Actually, this 3-axis position control basically used in the wood designing, 3D designing, wood designing. So on that, in that purpose, in order to control this, look at here, we have a drilling machine. Drilling machine makes some holes, and length will be cut by this one machine. Another machine is width will be cut by the another machine. Understand? Yes, look at here. This is our required PLC kit. We already write some program to this by our personal computer by using the ladder program. Then the program will be applied to the servo driver. Servo driver will decides how much of length, how much of depth, how much of width, all those things. Look at here, it will give 4 outputs. This output represents PSO1. This is Z-axis motor actually. Z-axis motor. Look at here. This PSO1 is used for position control of the drilling depth. It will decide the drilling depth. So the servo driver will decide the how much of drill depth is required. And second servo driver represents the x-axis motor. This x-axis motor will decide the x and y tables 2 dimensions position control. So look at here. This will decide the this length, and this will decide the another length, PS4. PS4 to PSO3 for XY tables 2 dimension position control. PSO1 is used for the drilling depth. So if you take some wood, from that wood making drills and making our required length and making our required depth, required width, at a time will be done by the our PLC. Required length, depth and height will be given by our personal computer programming by using the ladder programming. We do this. It will operate this servo driver. This servo driver having 3 number of motors. These 3 number of motors done our required work. This is one of the important application of our PLC. And next application is level controller. Look at here, in water level control. So generally in our domestic purpose or industrial purpose, we have water level control is very important. Otherwise water will be wasted. Otherwise the water will be wasted. In this here, we have liquid here. This liquid will be sensed by the sensor. So whenever the liquid will be reach this point, sensor will give the signal to our PLC, and our water level setting is decided by this water level setting, that already the program is written here in this our PLC. Whenever water level sensor is require this position, it will give signal to the PLC and it will operate the amplifier. It will control the valve. That means it will control the switch here. Then the valve will be closed, the water will be stopped. The water will be. This is also one of the best applications of the PLC. Understand? These water level control also done by our PLC, our programmable logic control. The program is done by our personal computer. Program and logic, the control is done by our PLC. Understand? This is also one of the best application. These are, I taken only these 3 applications, and we have more number of applications in our industrial and automation. But in order to understand how the applications are done by our PLC, I will take these 3 simple examples. But in our industry we have more number of applications. If you search, we will get more number of applications of the PLC. This is about our PLC. Simply, PLC is, we will write some program. The program will be stored by this CPU of the PLC, and it will take whichever the input is required and it will give whichever output is required. We can operate from here. This is the importance of the PLC. Okay, thank you.